Okay, hi guys. Here is this first review video, and there's 15 things that are covered in this. So make sure you read through this at some point because I'm not going to read through the whole thing. The examples don't start until the 6th one. Okay, so the examples start here. All right, so that's where I'm going to start. Those are the examples you want to take notes for. So the limit definition of a definite integral. So, all right, here it is. So you've got to know both of these limit definitions. And I'll try not to talk too much in this video, so make sure that you read what I don't talk about. Oh, and by the way, I like having parentheses there. But often it's not written with parentheses. So which of the following limits down here is equivalent to this? So my recommendation, if you see on the test a example like this, is first figuring out what delta x is. Or actually, I guess maybe first figuring out which of the formulas that they are dealing with. So I don't see a k minus 1, so I think that it's safe to say that we're dealing with this one here. Okay, so let's figure out what delta x is. So delta x is always b minus a over n, all right? And in this case, so that'd be 5 minus 3 over n. So we've got delta x is 2 over n. So that is going to allow us to cross off a and c. And now, after you figure that out, you should figure out what f of a plus, in this case, k, and then delta x, we just figured out is 2 over m. So it's really going to be 2k over n, I guess. Oh my gosh. Or k times 2 over n. And guys, you might be able to narrow the choices down now, but I'm going to go a little bit further. So anyway, this is going to be blank to the 4th. So f of x. So f of x is x to the 4th. All right, you could see that's the input on the integral. So it's going to be, so a is 3 plus 2k over n to the 4th. And then, yeah, so we see that it's D. That is the answer. Alrighty. And please let me know, guys, if any of this is unclear. Now, the limit definition of a derivative. These are the two limit definitions of a derivative. You need to know them because they could come up. But so here they're asking, what is the limit as h approaches 0 of this? This actually is the limit definition. It's this limit definition of the derivative of a certain function. But I used to teach it that way of trying to figure out backwards what the function is and then try to figure out backwards what is the input on that function, and that was a huge mess. So, and then I realized that you could just use L'Hopital's rule. Anytime they're giving you the limit definition of a derivative and they're asking you to evaluate it, you don't even have to figure out oh, they're basically asking for the derivative of this function at this value. I mean, they are, but you don't have to figure that out. You could just use L'Hopital's rule. So always try direct substitution first. So I'm plugging in 0 for h, and this ends up being 8 times a half to the 8th minus 8 times a half to the 8th over 0 equals 0 over 0. Now this is multiple choice, so I don't have to say therefore by obviously therefore by L'Hopital's rule. If it was free response, you'd have to. Oh, let me write that down because this is for our notes. So if free response need therefore by L'Hopital's rule, and you do not have to spell it right. Some people spell it La Hospitals, and they would get full credit. I guess it's just easier for them to remember. Okay, but we don't need that for a free response. So I'm going to take the derivative of the top. All right, so this is going to be the limit as h approaches 0. All right, and it's going to be the derivative of the top over the derivative of the bottom. The derivative of the bottom is just 1, because that's the derivative of h. But the derivative of the top, I need this for this part of it. So it's 1/2 plus h for the inside function, and then for the outside function, 8 blank to the 8th. The derivative of this is just 1. The derivative of this is 64 blank to the 7th, and then 1/2 plus h goes back in. So that's this. So it's 64 1/2 plus h to the 7th minus, because that minus, what is the derivative of this right here? That's just 0. That's just a number. The derivative of a number is 0. And then you do direct substitution again. So this is 64 times 1/2 to the 7th. Okay? And then I'll just use my calculator. 64 times... It is 1/2. Okay. Moving on. Implicit differentiation. This is when... Okay, so how do you know something is implicit differentiation? Okay, so it's when you need y prime, but y is not solved for. So the x's and y's are like mixed up. So the slope of the tangent line to this curve at 2, -1 is, that's what we want to find. Now, slope of the line tangent, that's the slope of the tangent line. You need to know that that is y prime. Okay? Like at the beginning of the year, we would say all the time, like, or I would ask you a lot, like, what are 3 names for the derivative? And it'd be the slope of the tangent line. Oh, or no, it would be slope of the tangent line, instantaneous rate of change, and derivative. Those are all 3 things the same thing. They're synonymous. That's what I used to ask. Okay, so we've got to find the derivative of every single term of this. And implicit differentiation is when you do chain rule for everything. So for this part, y squared, it's going to be 2y times dy dx plus, now for the derivative of this next part, I need chain rule, so I'll go off to the side. The inside function is xy plus 1, and then blank to the 3rd. Now for this xy, I need product rule. Prime. So x and y, and then, all right, so the derivative of this is 1 dx dx, and then you bring down y, plus x, and then the derivative of that is 1 dy dx. All right, so that's the derivative of the inside, and then times the derivative of the outside, 3 blank to the 2nd, xy plus 1. Okay. All right, let me just go like this. Xy plus 1 to the 3rd. All right, so I needed that derivative equals 0. I just want to maintain, like, the equation. Whoops. Okay. Now, in the next line, every dy dx, I'm going to replace with y prime. So this is 2y y prime plus this thing. Dx is just 1, by the way. So that's just, so plus y plus xy prime times 3 xy plus 1 squared equals 0. Now, they want y prime at this point. If you try to solve for y prime now, that's going to be a mess. So instead, at this point, you should plug in this x and y value. So, you know I'm a fan of blanks, so I'm just going to leave, especially when I have to do a lot of substitution, I like to leave placeholders like that. Okay, so in for every x is going 2. So I look for x's, there's an x, so 2 is going in there, 2 is going in there. And then in for the y's is going -1. Okay, so I'm kind of running out of room, but this is -2y prime plus, this is -1 plus 2y prime, and then this is times 3, and then in the parentheses is -2 plus 1, so that's -1 equals 0. So this is -2y prime plus 3 -1 plus 2y prime equals 0. -2y prime minus 3 plus 6y prime equals 0. 4y prime equals 3. I don't even have to finish it. This is multiple choice. 3/4. Okay. Now, related rates. So this was a long time ago. The radius of a circle is decreasing at a constant rate of 0.1 centimeter per second. In terms of the circumference C, what is the rate of change? Okay, so anytime you see here rate, that's a derivative. Okay, rate of change. What is the rate of change of the area of the circle in square centimeters per second? So these rates, let me figure out, okay, the radius of a circle is decreasing at a constant rate of that. So this is going to be r prime. That's the rate of change of the radius of the circle. Yeah, so that'll be r prime. In terms of the circumference, what is the rate of change of the area? So that would be a prime. So they want to know what a prime is. What is the rate of change of the area of the circle in square centimeters per second? Okay, whenever you have rates, okay, it's a word problem that involves rates, you should do this. You should go no, want, and then when. Okay, so what do we know? We know that r prime equals, now it's decreasing. They're going to tell you if something is increasing or decreasing. If it's increasing, the rate of change is positive. If it's decreasing, it's negative. So -0.1. What do we want? A prime. When? We don't know. They're not telling us that they want a prime at a certain time. Okay? So here, they're not giving us a when. So they want a prime in terms of the circumference C. Okay, the next thing you do is you write down any and all formulas that apply to this situation. So here, the circumference of a circle and the area of a circle. And then you take the derivatives of those formulas using implicit differentiation. Okay, so the derivative of c is 1, but then you do dc dt because it's in everything is a function of time. So you're taking the derivative with respect to time. So anyway, it's just going to end up being c prime equals 2 pi, but then with an r prime. And then this is a prime equals 2 pi r prime, okay? Alrighty, they want a prime. They want a prime in terms of c. Okay, well, all right, what we know is this. So this can go in for that r prime. So a prime equals 2 pi r negative 0.1. Now look at the choices. Do we see anything? Oh, well, I can cross these off because we're not squaring the 0.1. So that leaves me a better chance of guessing correctly. And then guys, look at all of your formulas. Look at all of them. Anywhere else do you see a 2 pi r? Yes, right here. That is c. So a prime, this is c times negative 0.1. So it's b. So that's like a system of equations, basically. All right, continuity, I'm not doing an example, but conditions to look for, if these conditions are true, continuous, and then if you're ever asked to explain why something is continuous, it's got to go like this. Show the 3 conditions hold, blah, blah, blah. Alrighty. Now, the equation of a tangent line. Alrighty, so which of the following is an equation of the line tangent to the graph of this at the point where f prime of x equals 1. All right, now actually this is going to take me a little while and the bell's about to ring for a class. So I'm going to have to do these videos in parts. Okay, so I'll pick up here later.